For this problem, we are considering a large rotating cylinder. So it's a large hollow rotating cylinder with radius r, and inside the cylinder we have a person of mass m. So what is happening is that the cylinder starts rotating on its own axis. It rotates fast enough that the person inside sticks to the wall of the cylinder, and the reason the person doesn't slide down is due to the friction between the person and the walls of the cylinder. And we're also given the static friction constant between the person and the cylinder walls. So now the question is, okay, what is the slowest speed that the cylinder can rotate at so the person doesn't slide down? So to do that, we first consider, okay, along the radial axis, what are the forces on this person? The first one is just the normal force, which points radially towards the center of the cylinder. So perpendicular to the wall, it's going to be equal to the centripetal force of the rotation. And on the vertical axis, that's where we're going to have the friction, because it's preventing the person from sliding down. So the friction is going to be pointing up. So we have μs, that is the static friction constant. That's the normal force equals the weight of the person. So in order to find the period, but remember, well, this velocity is going to be equal to 2 pi times the radius over the period. So doing that and also dividing these two equations by each other, we are left with this relation here. And from here, we can just directly solve for t. It's a matter of passing t over here and then taking the square root. So we're left the smallest speed the cylinder can have, so the person doesn't slide down, is 4 pi squared mu s r over g. Now we can ask the question, well, what's going to happen if t decreases? So when t decreases, that means the cylinder is spinning faster because it takes less time to complete one full rotation. So the normal force on the person due to the walls is going to become bigger, which increases the friction force, so the person just stays on the wall. However, if t increases, then that means it's taking longer for the cylinder to complete a full rotation, so it's spinning slower. Because of this, the friction force is going to decrease, and the person will start sliding down the wall of the cylinder.